design coders, decoders, camera stuff, and this makes the software design very complex. So you also have various components which talk to each other, and uh, it brings a lot of traffic, and this traffic is most of the time simultaneous, and it leads to DDR utilization, and there are many issues with that. Uh, so in order to solve all these issues with uh, bandwidth and all these multiple sources of traffic, the on-chip interconnects has evolved. So first we had some simple buses which are shared with, like we have an arbiter who control who speaks on this bus. Then uh, people started using crossbars, which is just all the inputs are connected to all the outputs, and uh, this takes a lot of space, and there are many wires, and this leads to some power management related issues. So the next step of the evolution was the network on chip concept, which just is something very simple. It just works in a similar fashion like the internet today works. So it uses packet communication protocol. So you just have some packets with header and payload, and in the header there can be source and destinations. Um, so in the network on chip, you have a topology with multiple nodes, and each node acts like a router to forward the traffic. And there can be various benefits for this. You can use multiple links, or you can use quality of service parameters, set priorities, and that kind of stuff. So here is a simple diagram of one real-world SoC. So you can see we have memory front end. There is a system network on chip, configuration, multimedia, and to each of these buses we have connected various devices. So we can have here CPU, modem, GPU. So the traffic flowing between the memory and the system node. There are multiple links between the nodes. So the traffic can flow in these directions simultaneously and gets aggregated here. And this path, for example, between these two endpoints, it can have a separate block or a specific. So you can set some bandwidth for this link, and this bandwidth can lead to some to program some low-level registers to set the minimum possible power profile in order to and to function correctly and to have the needed performance. But at the same time, you need to keep the lowest possible power profile. So here is, for example, want to access from the CPU to some shared memory. We have to go all these paths. So these are the endpoints. I call this paths. And
Surely it does not end up in DRAM.
yeah, this is a shared memory.
Now
Yeah.
with memory, you said that's memory. The box that the CPU is tied to.
Yes.
That's actually the memory that's this
Memory
one which
front.
the memory
This
is
is memory
connected. That's an internal bus. It's we call the bus front end of the bus.
Memory front end.
The memory.
So we can all this connect. This memory front end. Yes,
Yes,
something similar to AXI bus, yes. But yeah, there are various companies providing this solution from custom network on chip stuff, and yeah, there are some vendors trying to innovate on this, create various solutions. So actually the socket interface with to plug to this network on chip concept, this is standardized, so you can reuse, uh, connect all these peripherals in a standard way, this network on chip. So what was the problem here? Problems are that, yeah, this brings a lot of benefits, but it's complicated to manage this, and especially from a Linux perspective. So you can have multiple drivers, for example, controlling USB hardware or MMC hardware or some video decoder stuff. And the goal is that all these drivers can report what kind of bandwidth they need between two endpoints or more endpoint pairs. And according to that, uh, we can tune the hardware to keep the lowest possible power profile. At the same time, get uh, the needed performance. Uh, so yeah, currently how this is solved. So usually each SoC vendor who do something like this, they do some stuff in their downstream code, add some hacks or just add some clocks or some register writes and solve it in their own way. So I'm trying to solve this by proposing a solution for the upstream kernel that will handle this case. Um, so I have been working on a thing I call Interconnect Framework, which has been maybe over a year for now. I have had support for currently two Qualcomm SoCs, and the third one will be coming hopefully soon. So how I have organized this and what is the design. So similar to some other frameworks like blocks and regulators. I have all this as consumer provider model. So interconnect providers are basically a platform or SoC specific drivers that contain all the network on chip topology, or actually this can be used with any bus, or not only with network on chip. So I'm trying to uh, create this in a generic way so that it can be used with anything and could use with more people. So the provider just have the topology and then to implement the low level functions which exactly set the configuration to the hardware. So this is platform specific, and also for the network on chip, for example, we can have some custom aggregation. So through one node, you can have several traffic flows that need to be aggregated. So I'm also providing custom aggregate callback, so the platform could just make a sum of all bandwidth requests, or want to use the maximum, the peak request for that. On the other side, we have interconnect consumers, which are just the device drivers. Could be anything, video decoders, GPU, USB, MMC, all kind of peripherals. Even, yeah. So they use simple get and set functions. They get path, set some constraints on that path. And, so yeah, here is how the provider API looks first. Simple functions, just as a provider, nothing here. And this is the consumer API. So currently we have ICC from interconnect controller to get use some IDs, so we can use this with platform data. So we first started with platform data. And then we have wrapper function for device tree. I'm not sure actually. Probably at some point we can add some ACPI wrapper. I don't know if we have something similar or any other platforms from on-chip interconnect. Not familiar, but in the future we can add this if needed.
Depends on the type of thing that does be nice if that was actually somewhere.
Mhm.
I just have a question about the sort of things should be solved in the job.
Yeah. Mhm. Yeah.
But you said you have support for two Qualcomm chipsets.
Yeah.
Nothing radically different?
On the third one, there are some differences.
But it's also Qualcomm,
It's also Qualcomm.
Yeah.
but not a MediaTek or any of
No.
the other ones that
No.
are typically different.
Yeah. So that's why I'm sort of my phone. The questions I have are because somebody know of anyone who is using something similar, or
Traditional like the mobile phone also
Yeah.
manufacturer are scaling their use. So probably some preparatory stuff.
yeah, but I think it depends on the level of complexity.
But you said this is an attempt to generalize something, right?
Yes.
Can you demonstrate how to be generalizing those, like, but how the existing things could be implemented in terms of your solution, for example?
Uh, how the existing things can be implemented in this
Yeah,
solution.
in terms of this, yeah, how, how, if, say I am a vendor and I have a custom implementation somewhere, if I want to use your stuff, what do I have to do?
Yeah, so you just need to create a platform-specific driver, which will contain the topology, for example. So it can be any kind of topology. And you need to implement the set function mostly. So the get function, you have two identifiers for source and destination. The get function, what it does is it walks the path, so looks into the platform-specific driver to find out if this is a valid topology and returns some handle to a path. And then you manipulate this path with the set function. And this calls the platform-specific implementation to handle this. So if you're a vendor, you need to first add a platform driver with the topology and implement the set function.
Okay, so if you want to argue for this approach, I would suggest to take one existing thing and try to re-implement it using your new framework.
Yes,
To show that, yeah, this is how to do it, as an example.
yes. Yeah, I have this. I did it for two SoCs, and because all they are Qualcomm SoCs, I'm trying to gather some feedback on maybe someone else if
The
wants
main
to use
problem
it.
is that there is no thing similar in mainline. It's more in some direction kernel for sub-vendors. So difficult
this is vendor
to,
kernel.
yeah, it's vendor kernel.
I see.
That's fine. Goal is to try to make them come into a direct solution in mainline instead of keeping
Okay,
them.
so to avoid the version of this codes into the main line, okay.
Yeah.
So,
Yeah.
Does
Yeah.
this work with F3? Does it work with F3?
No, currently not. So
If I can
In-
probably get some information. The goal is to
Yeah.
know the boundaries needed in the interconnect
Yeah.
and to set up. Yeah, you-
So currently for a lot of Qualcomm chips, that's done on F3.
Only
Basically,
for it's,
for the interconnect and the bundle. You said that.
not for the interconnect, right? But for the DDR.
For the interconnect as well.
mostly for
Pretty
Yeah.
sure about that.
You need
For DDR and all, it's not difficult, but for
Yeah.
others, but it's not, and you don't have any.
yeah, I'm pretty sure.
But on other vendors, they'll reach into the interconnect, read some counters, and then determine what frequency they want on
Yeah.
their
Yeah.
memory controllers.
Yeah, but this is the reactive approach. So
Yeah.
in this case, you know everything in advance and just set it, and you don't get any
That
boost
is more
screens.
like a DDS bandwidth and all, DDS scaling happens. But this is more like a, like for example, you know the protocol in advance, for example, you operate in a book. Based on that, you know how much you want to bandwidth from your side. So on the buses.
Yeah, it's suboptimal.
Yeah.
Hey, what different firmware can do here?
Do that.
Yes. Yes.
Okay.
This is an option.
Because honestly, firmware can take care of all that.
But it will depend on the vendor. So I
That
don't
approach is-
think, you know, you can say. I was just asking because I think in an enterprise system probably you just need to share variability. And they could actually do some practice.
Yeah, well,
They can see when you put your whatever. Or whatever.
I would think
Yeah.
you have things like CSCI, where you format, run power management to the firmware. Then I don't think you can put stuff like that in the kernel in parallel with it.
Okay.
Because they will just clash.
So that doesn't prevent the interconnect provider. That doesn't mean that we are accessing register. That can just say to PCI or SCMI, we need such kind of performance because we know that USB, SPI, video decodec in this language. That's not the point. The goal is to collect some smart information that the firmware can get. The firmware can just monitor and react, and then just say, I know I need that. And then you can say to the firmware or whatever is controlling the boundaries, you need to set to this value. Don't waste your time trying to guess estimate what is the one it. We can give you directly what it is. That's the point. It's not to be instead of some firmware, it's just to be uncoupled.
Okay, so that's a way of providing a key
Yeah.
to the firmware, that's fine.
Yeah. Yeah, what we call the interconnect provider, it will just aggregate all the information, and then either it's directly accessing hardware, or it just CMI or PSCI.
If it is a multi-OS thing, like one firmware be more aware of both the OS and aggregate at the firmware level rather than each OS doing
If
its
it was
own.
multi-OS and there is a primary device, Islamic instead, this is what I think is happening.
Yeah.
I think what you're saying.
Yeah, like, and also with abstract scaling, like I don't know how much Perl is doing something in the frequency scale and then everything is abstract and just adding them together might not make sense.
Yeah, but in that case, it's still the firmware that defines what the abstract scale means.
Yeah, but what I'm saying is each component might have its own abstract scale. Aggregating simply might not give you anything.
No, but if the firmware provides an interface, you've got to define the limits of layers. So when the clients come in, otherwise it never work. So that's how some performance, right? But the performance management, that's how it's done. The firmware defines what the scale means.
Yeah, but what I'm saying is all of the scale need not be like all of the frequency or whatever performance need not be on the same scale. And only from there knows that knowledge. So if we try to aggregate in the kernel.
Oh, no, I'm sorry, no, but I'm confused. I'm saying the aggregate, I'm saying the different clients come in as I want, and the firmware
Yeah.
does not.
The only way it can work. Okay, what is also important. But so avoid synchronization of it, like blocking all because then you will get a very nasty synchronization problem. That's a lot of time. So that is the firmware, and then it will move to right
Qualcomm case, some of this, in some of the cases, this set function it it communicates with remote processor, and yeah, so there not only there can be not only register writes or scaling some clocks, but just send a message to remote processor, and that's it. So these are actually most of my discussion points. So there can be cases where the consumer driver might not know its bandwidth needs. So for example, if we have a UART, the UART knows the baud rate, so it can calculate the needed bandwidth. In the video decoder case as well. So if you know the resolution and
What's the count example of the counts?
there are some cases. There could be some specific stuff.
So if you talk about that as things, then the first concern is not a concern because you just are to provide a thing. In that case, and when something happens, but you still don't know what should happen, so whatever happens is okay. But if you know, if you happen to know what your needs are, you can't provide a thing, and then influence
Yeah.
what happens. But if you don't know,
Yeah,
Get the lazy guy, doesn't know, so just asks maths, right?
yeah.
Max is good.
It's good for you.
For power savings, especially.
that already assumes that you know something, but you know that probably your
But-
performance oriented more than anything else, right? But if you don't know anything,
But I've also experienced people whose job is to just program one driver, and they think it's only running all that.
oh yeah, but
Funnily enough, that shit works really well, and everything goes broken.
Okay. So yeah, for this case and also for the second form, my suggestion is to encode this information on ARM platforms, at least in device tree as OPPs or something. So this is the direction I see to go.
I'd like to maybe offline chat about that.
Okay. Okay. The next one is something very specific. Yeah, slide for this. So this is on Qualcomm platforms. So we have remote power management processor. We have Linux CPU, we have modem, we have various stuff. So the power management and resource control is done via this processor. And the Linux CPU, it can power collapse. So we have two states, an active state where this is active and the sleep state where this is power collapse. So Qualcomm have these two kind of sets. So when the Linux CPU is active, there is a vote for specific resource. So for example, some millivolts, some frequency. This vote is sent to this CPU. And when Linux CPU is power collapsed, before power collapse, it sends some other vote for resources which might be needed when this CPU is asleep. And this CPU, it does the aggregation and set bandwidth, set voltages, and it controls various resources. So in the case for interconnects, we also need to do something. So this is same thing we have also for clocks and for regulators, and there have been some discussions on the mailing list for voltage regulators, for example. It was proposed to have a regulator with so that we can have a pair regulators for sleep and active state, but this was enacted by Mark Brown. For the clock framework, I have upstreamed some solution which just so each resource for active and for sleep has a different name, which is kind of ugly, and I don't want to do with interconnects. So I'm wondering if any other vendor is using a separate CPU for managing resources, and is this a common case?
So they have this active and sleep state, these two states that can be communicated automatically.
Yeah, so I don't know whether only Qualcomm are doing this, or I guess other vendors might do something similar.
That's sort of akin to the system controller plus. So, all of this kind of rested on that.
Yeah.
Yeah.
Okay.
So one other thing. So all of these are odd numbers or
Yes.
it's in the other standards?
Okay. Another problem is when we do descaling, actually during kernel boot, this is a problem I have right now with my framework. When the first boot arrives, so the UR, for example, the UR driver probes and it sends a request to the framework telling it that I need some minimum bandwidth for the UR. The framework scales interconnects to some lower level so that this can impact the boot process until all the other consumers of this interconnect are registered and the votes are correctly aggregated. So we have URs, then at some point the display driver registers the request, then GPU and video encoder and so on. So there can be some slowdowns during boot. So currently I'm trying to use, there is a patch set by Viresh Kumar, who is called, and the patch set is called boot constraints patch set. What this patch does is it keeps the resources. So it's mostly for bootloaders when we have a resource enabled by the bootloader and we want to keep it enabled until the specific driver which uses this resource is registered. For example, this is a common case with display and splash screens from bootloaders, so that we don't have any glitches on the screen and that kind of stuff. So currently I'm using this patch set for interconnect, and it seems to work, so that we have some minimum vote for performance that does not impact the boot process. Basically, we set some bandwidth between the CPU and the DDR memory. And yeah, when boot is finished, all these votes are released. Also, this is one of the problems I have, and this is how I have solved it. I think that's it. Any comments, questions?
So I'm just curious, how much of this can you do with the common clock framework stuff?
Only scaling clocks, but the common clock framework maintainers don't want us to use the common clock framework from DVFS. So some complex.
But it's not dynamic. The parameters are static, you said, right? Like it's set in the DT or whatever.
No, so this framework allows configuration on demand. So for example, you play some video file, depending on the resolution, the video decoder sets some bandwidth, and if you play some other file, it may have a different
When you
resolution.
plug in a speed to the speed device.
Yes,
Okay.
yes,
Yeah.
yes. Also, yeah, also have an idea to integrate this support into subsystems, for example, with USB, depending on the USB standard, or if you put a specific MMC card, so you can know what kind of card it is and how much bandwidth it requires. So this is one of the further steps.
There is, for either PCI standard, is a concept of LTR, which is latency tolerance supporting, which sort of is similar to this, because the components can request specific, you can say that they can tolerate specific latencies on the bus. And that was, at one point, sort of included into Eclipse OCs with RCPI firmware, and we implemented support for it through PMQoS. And it is there in the main line.
Yes.
So, question is how different this is from the other thing, and because this looks to me like a QoS problem.
Yeah.
Point is creating this topology because the constraint to QoS value that you need can be different along the path, just because you can have different paths which have some common node. So it's just not saying I need this for the system. It needs to be set per node. We started to have a look at reusing PMQoS, but it was
Yeah, but for LTR, you have the same problem because different is like there is a bunch of components and they are in a like share, right?
Yeah.
And then one branch can request something, the other branch can request something else. And you and to some extent, and some of those components have registers where you can just write those values, but some of them don't. So you have to a point you have to aggregate the software, and then when you find a component in the register to write it, you just write the current value that you have aggregated so far. So it seems to me that that could be maybe done in a similar way, but in the same way.
Yeah, so do you suggest to use only the PMQoS or use the interconnect framework, and that the interconnect framework could use this?
Look at the existing code.
Yeah, yeah.
Let's see, how much of it covers your use case, and maybe it can be somehow or instead of the framework, or hook up somehow to it. I don't know. I need to look at it. I can not be following the path honestly for various reasons, but
Yeah.
I need to look at that.
Yeah, actually, I have looked into the PMQoS, but
So I would like to avoid having concurrent, solutions for the same problem in the dealing with it in different ways.
Yeah. yeah, I agree with this.
Yeah, it's yet another framework in the kernel.
Yeah.
That's the obvious.
Having another framework is fine as long as it's
Yeah.
the use case is distinct enough.
Yeah, exactly.
Because
Yeah, I have looked into various subsystems for this, and also have considered using GenPD and various subsystems, but yeah, just there are specific requirements like these multiple paths between devices and all this encoded into some black box platform driver with all these different types of constraints and these custom aggregations. So the changes to the def PMQoS might be significant in order to handle this case. And it might
not
be,
necessarily changes, you can just add something to it, because the influence is based on sort of on classes, like you have
Yes.
different classes of requests. And then, so for LTR, we actually added a new class. But the interface is the same from user space perspective, because what I'm thinking about is the user space can actually have information about what the design requirements are, because user space is, say, a video application or similar, and it knows just the frame rate it is going to use, and it may know multiple things in the kernel doesn't know. And now it would be just to have an interface for this process to tell, to tell the kernel or generally, to specify each view of the current requirements or what it would like to have, what I can get from hardware or from the platform.
There is another thing that right now all this topology is not there in the kernel. We don't have any device on which we can apply this kind of QoS. So we need to create this
Oh yeah,
topology at the point.
sure, but in any case, so I think, your knowledge about what's needed may help you make right, or it may be that.
Yeah,
Yeah, the problem with this is mostly that there can be hundreds of nodes, and each node in this case should have a struct device and not very big. And I don't know. Okay, other questions, comments?
Are you still collecting data on the benefits of the interconnect scaling?
Yes. For model drivers, and they actually plan to add some other types of constraints, not only bandwidth, but priority and for QoS values latency.
maybe that's because right now you have average bandwidth and peak bandwidth, and
Yes.
what makes sense be generic. We were speaking about some kind of latency, but
Last time we discussed this problem, we figured out or proposed about identifying paths, so you can set a in for a QoS value on a path between two devices. And then the representation of the path between the two is irrelevant as long as you can figure out things. For the driver, an interface for the driver, I would like to have, if I was the author of the driver, would be to be able to say, I want a specific bandwidth between myself and the other device.
Yeah.
And whether or not there is an interconnect between us, I don't care.
yeah, that's the goal. But the
Yeah.
point is that what the driver want to set. So we have this average and peak bandwidth just because you can have an average bandwidth, for example, of 1 megabyte, but you must make sure that but the peak bandwidth is more something like to reflect some kind of latency or responsiveness.
Yes.
And that's what's the best way to describe that? Why? Because you have this average value, but you sometimes need that as a burst. I mean,
Oh yeah, but the purpose and generally speaking, so you probably be able.
that's what we have, but we have assumed that speaking about bandwidth, so average and peak should be easier for a driver because latency, I don't know for, we were discussing about, for example, for USB driver, if we want to set the latency, what is the value for a USB driver? Which kind of latency? How to define that straight between in and the memory, for example?
Well, so latency, they manage for granted correlate.
Yeah.
Latency is because of distance in time.
Yeah.
Between two events, like this and that event.
Yeah.
And so you basically now what events here, but then otherwise, it's just not defined.
Yeah, the time for a packet of data to reach the target. Yeah. And the maximum, for example, the maximum time to go to the memory, for example.
So that has to be defined.
Yeah.
Anything else?
In Intel platform, everything is done by the firmware. You are very
Not
small.
everything, so say LPR, for example. That's not those Intel specific, as I said,
Yeah.
it's the ACI standard. So this is just an expression of the fact or thought that there may be some sources of information outside of the platform firmware that it needs to be taken into account. And I think that advice for that, to provide. And yeah, these are those cases. Honestly.
Okay, thank you.